Okay, let's get started. Woo! Yeah. Anyone lost a phone? Phone, black phone. So I'll put it here. Meanwhile, if you. All right. Thank you so much, everyone, for making it here. Thank you. Really, really appreciate it. Welcome, Effect Miami. So I'm really, really psyched to be here. Like this has been like a dream for me, like a dream come true. So like I've been thinking about this for like a year, and then like luckily last year, like a month or so ago, I met Dax at the AIE, and I asked him about it, and he said yes, and now we're here. So this is pretty awesome. Thank you so much, Dax. Really appreciate it. Also, thanks Eyal for saying yes immediately. So I really appreciate it, and thank you so much for this beautiful space, the lab. Glad to be here as well. Thank you, Effect Core team, for letting me do this, and also thanks Max for making it here. Maxwell from the Effect Core team. And also, last but not least, thank you for my wife for helping me out and for supporting me in really crazy ideas that sometimes I don't even believe on, but she helps me out. So that's it. So let's get a feeling for the room, just to understand like who's here and what's your background. So who here has like a effect production experience or like has put it somewhere in production? Awesome, Dax, great. That's good. Dax and Max, sounds good. How about personal projects or just nice? And how about learning about it? Who's really interested about learning about it? Hardcore, right? Awesome, nice, sounds good. How about other backgrounds that are not engineering, like maybe design? Any designers in the audience? Nice. Okay, no designers. How about product people? All right, good. Sounds good. It's the right crowd. So the title of my talk is called Effect Plus AI and why declarative software matters now. I think this is like a really good sort of introduction to Effect, but also is the core of why I really care about this meetup, because it's more about like why declarative programming is so important in the age of AI. And definitely, like, I think Effect is one of the best tools to do it, if not the best one, but that's my opinion, of course, again. So and in general, like the main thesis is that with LLMs we got to the point that implementation is fast and cheap, but understanding is still not optional. And declarative programming helps us understand actually what we do. And that's why I think we should really get into Effect, especially now with AI. So let me point out a little bit for those who don't know. So how many people know what declarative programming is here? Probably a lot. Nice. Cool. So declarative programming is really about making explicit constructs when you program. So it's making like a runtime contract, and that contract in generally by explicit, it means that the definition of it depends on the types that it's that's stated. So for example, for an effect construct, you have an effect construct can succeed with a type A, or it can fail with an error of type E, or it also needs requirements of type R. Whereas like something like a promise, which is more implicit, then the meaning of a lot of things that happen in a promise happens sort of like distributed around without being like fully or explicitly addressed, right? So failure, cancellation, dependency, all of that, you could do it, but you have to do it separately. So it's not part of the denotation of the explicitness of the construct. So what I will cover in this talk is first, like, why do I care about this? Why is it so difficult to adopt this in the industry? But also how AI actually changes like the equation now on adoption, and how it actually, I think, it flips things around. I'll talk a little bit about like some hype terms that we have in the AI community that I think might be counterproductive, especially for more junior engineers. And so what is it that effect makes explicit? I talked about that a little bit. Why effect is hard, and why I think like AI plus effect is kind of like a yin yang. And I'll touch a little bit on Schema, which is kind of a passion of mine and something that I've been working personally, but I'll go really fast. Maybe in the next talk, I'll cover it a little bit more. So personally about me, I was born in Israel. I was raised in Argentina. Then I came to the United States. I studied pure math in Florida State, so here in the state. And then I did some research at Carnegie Mellon, and then I went to industry. And then in industry, I actually went all over the place, right? So I started in machine learning, but then I got interested in data visualization. I don't know if you guys know Mike Bostock, but I got really into that. And then, so I started doing a little bit of functional programming at a company called Platfora within CoffeeScript and Knockout.js. And from there, I jumped more into product and sort of like leading like product more from a design perspective in Nokia. And anyways, I did consulting. I did like more like engineering platform management and so on. But as you can see in my resume, I jumped all over the place. But my point is that there's one thing that remained constant, and it was my interest in functional programming or in declarative programming. So I tried to apply all of these different things wherever I went. But actually pushing FP in the industry is quite dreadful. So that's the honest take, right? So especially like in corporate environments. So if you ask me, like, would you do that again? I would honestly say no, because the reality is that, you will learn a lot, and that's kind of why I did it, because I was really more interested in learning it than actually, the actual positions or things like that. But in general, like if you want to climb or something in a corporate environment, I would recommend you not to do that. But I will explain you also some reasons why I really valid about like the resistance that are in the adopting like declarative or like things like effect. So things like steep learning curve, it's hard to find talent about it. There's a lot of pressure to deliver in organizations, and they usually prioritize implementation before specification, right? So. And they also don't want single points of failure, right? Because if you do something and then nobody knows effect, and then who's gonna fix it? But AI definitely changes the game, right? So it's worth analyzing what happened. So one thing that changes is that now learning is way more accessible, right? Like you can ask the AI, and it's about you sort of like saying, okay, what is it that I don't know, and going back and forth. So that definitely changes things around, and it allows for more talent to grow. Also, that you don't need to know things fully if you understand them conceptually and you work well within certain boundaries. You can definitely, sort of like start contributing and then learn as you go. There's also a high incentive for learning, because obviously they don't pay us anymore to implement, so we gotta learn something new. And LLMs help also like speed up like immediate needs. So, it gives us a little bit more space. But something that really cannot be changed is sort of like the organizational structure or organizational culture. So you definitely need a culture that actually welcomes that, and that's very, very difficult to find. So why does implicitness get expensive, right? So right now, the point is that before we said like, okay, if we do implicit or we just follow the happy path, we save money, we save developers, and who cares at the end of the day? If the computer crashes or something, they'll deal with that later. But the point is that like AI makes implementation cheaper, but unclear abstractions still compound complexity. And specifically, if you're pushing more code with AI, then that complexity is going to grow exponentially really fast. Right, so That's what happens with like unhandled cases become harder to track and call growth, right? So agents need precise abstraction so that they can change the software reliably, right? So if you have these explicit constructs in your program, then it allows you to more confidently ask the AI, hey, change me this part on the infrastructure or add me this feature, as long as you have some sort of like declarative, explicit understanding on your code base. So as I said before, like there's a lot of like AI hype terms that, you know, I say them as well. I'm not morally making a charge on that, but it's worth like understanding like the details on them. So one of them is like, in general, we say like coding is dead. And again, AI makes implementation fast and cheap, but understanding is still not an option. So software is also about building abstractions. It's not just about code output, right? So, and I understand, but if you look at like coding is dead, and you know some junior engineer thinks about it and sees the power of AI, they will think, okay, there's nothing to do in here, and maybe they're right, but I'm against that. So I don't agree with that. So the other one is that we also say that English is the new programming language. But so you can drive agents with English, and I think that's extremely powerful, and I love it. I'm not against it, but English is implicit. English is not a language, right? So I'm not going to give an example of implicity in English because it happens 99% of the time that you speak it. So the real shift that I see is like from producing code to specifying meaning, structure, boundaries, and behavior, right? So I really think that we're shifting towards like really focusing on that and doing that well, so that we can actually, do runtime agents and then maybe treat our agents in a higher order. So again, like what does effect make explicit? It makes a runtime contract that is dependent on types A, E, and R, as I explained before, but it also includes things like is simple, is precise, is composable, and is reusable. I don't know notation what's there, that's definitely the AI. But the runtime now this construct also contains logic for retrying, canceling, tracing, scheduling, running like concurrency, and a lot of things, right, that a promise doesn't give you. And why is the effect hard, right? So a lot of people see the syntax and say like, okay, you have a star and yield and all of these things, and it looks really weird, and it's not JavaScript and it's not TypeScript. But the real difficulty is really not the syntax, because we're all familiar with multiple languages, right? So the real difficulty is the explicitness. But that explicit is actually what gives it the value. So my point is that the difficulty is clearly justified, right? So the explicitness creates you precision, but you still need to state it. And then that precision is what humans and agents need. So effect gives you a vocabulary of these constructs that you can use, right? And once you start like understanding a little bit more about like what does it mean, because the construct says the what, right? So once you understand the what of the things, then it gives you an easy way of like building interfaces with it. And if you use these constructs together with your LLMs, then they will also understand what it means. And if you put boundaries on your LLMs when you're coding with effect per se, then they'll be able to respect those rules. So yeah, anyways, I'm not going to go through all the modules, but my point here is that there's a vocabulary for it, right? So what makes effect an AI sort of like this yin yang? And I think it's a big claim, and I mean it. I mean it in the sense that you have higher level agents, so declarative programs reduce your context size, and also eventually if the complexity is lower, then they will reduce your token expenses. You get safer runtime, so you really want that for autonomous agents, because you want explicit semantics, make autonomous system more reliable. And then for example, something like effect schema is able to bridge you the probabilistic output into types and executable structure, right? So LLMs prepose meaning, effect makes that meaning executable. About schemas, so schemas are really, really interesting, especially in V4, because they're like first-class objects, right? So schemas are values that the system can inspect, compose, transform, and derive from. Schemas have bidirectionality. So schemas can define both the external data, how the external data becomes a runtime meaning, and how that meaning is encoded back out. So pretty much it's kind of like a twilight, right? Like that's the way that I see schema. Is you have like the fantasy world in which like you can run probabilistic outputs and you can have all the imagination you want, and you can ask it different things, and you can iterate with your LLMs, and then effect says, okay, I understand that. Now you gave me kind of what I wanted. I can convert it into executable code. And I think that's extremely powerful in the future. The other very powerful thing about schemas is the issues as a feedback. So in the asynchronous syntax tree of a schema, you have errors that sort of like backpropagate. So with description, with annotation, with schema version. So imagine all of that is your decoding data, and you can actually turn it into encoding and give it to an LLM. So therefore, what it means is that issues in schema work as a type propagator, as a type backpropagator. And if you know what a backpropagator is what the AI is actually used to train. So it's really weird, but this is kind of like in the executable version of that. Or maybe I'm wrong, but at least that's the way that I see it. So imagine getting that trace, giving that to an LLM, the LLM reasoning about it, and then it's saying, oh, okay, now without losing the meaning of your program, I'm going to derive a new schema that actually addresses that. So that's what evolvable software and evolvable data models are, right? And that's also another huge thing why I'm super excited about it, because if you have, say, in your organization, you have a loop, and you're not only encoding the code, but also like the way that you act, the way that you are expecting inputs and outputs. This definitely gives you a model of being able to sort of like iterate faster and understand deeply what's going on with your users, what's going on with your software, what can you do better. So that's pretty much all I had. So what should we take about it is that we have an effect meetup group to share learning, to do some serious engineering, to try to use this technology that I think will be very impactful in the future. Personally, for me, FP has all been something that I've been passionate about throughout my career, and that's why I wanted to have this here, that I'm currently in Florida now. As I said before, like the adoption in the industry is very hard, so we're not denying that, but also I think it's easier with AI, and I think that gives us a lot of opportunities for entrepreneurs, engineers, people that want to do new things to actually compete with giants that are used to a completely different pattern. We've clarified some misconceptions that by no means I think they're made intentional, but I think like if you go to a doctor, the doctor doesn't give you like just a diagnosis or like, okay, coding is dead. They will give you something more accurate, and I think sometimes we gotta use that responsibly. Why declarative code was important and why effect helps you in that process. We talked about why effect is hard, but it's hard because it makes things explicit. We've talked about why effect and AI are kind of like a yin-yang combo. We talked a little bit about schema before and the future of schema. And that's pretty much it. So thank you. My name is Ariel. Thank you welcome to Effect Miami. Thank you so much.